Welcome to Databricks video series from Daimlinc. In this video, we will learn about Databricks Delta Live Tables, an intelligent framework for building reliable, maintainable, and testable data processing pipelines. Delta Live Tables. It's not an object type as it may sound like. Rather, it's a framework that allows analysts and data engineers to quickly create production-ready streaming or batch ETL pipelines in SQL or Python. DLT allows you to define your data pipeline processing declaratively, which simplifies ETL development. ETL engineers can use DLT to focus on delivering data rather than operating and maintaining pipelines, allowing them to take advantage of the key features. Since its inception, Delta Live Tables have grown to power production ETL use cases with leading companies all over the world. Over 1,000 businesses, ranging from startups to enterprises, use DLT for their use cases. That includes ADP, Shell, H&R Block, Jumbo, Brit Finance, and JLL. What you see on the right side of the screen is how a data pipeline built with DLT look like. Many IT organizations are familiar with traditional extract, transform, and load, so-called ETL process, as a series of steps defined to move and transform data from source to traditional data warehouses and data marts for reporting purposes. However, as organizations morph to become more and more data-driven, the vast and various amounts of data, such as interaction, IoT, and mobile data, have changed the enterprise data landscape. Conceptually, it sounds easy to build ETL pipelines, something data engineers have been executing for many years in traditional data warehouse implementations. However, with today's modern data requirements, data engineers are now responsible for developing and operationalizing ETL pipelines as well as maintaining the end-to-end ETL lifecycle. They are responsible for the tedious and manual task of ensuring all maintenance aspects of data pipelines, such as testing, error handling, recovery, and reprocessing. This highlights several challenges data engineering teams face to deliver trustworthy, reliable data for consumption use cases such as complex pipeline development, lack of data quality, end-to-end data pipeline testing, multi-latency data processing, and data pipeline operations. There is always a slog from query to production. There is tedious work required to turn SQL queries into reliable pipelines. To list a few, there is dependency management, where you need to make sure you update the tables involved in certain order, where you need to use an orchestration framework like Airflow or Oozie or Azure Data Factory, etc. to accomplish that. Next, there need to be a framework to build daily partition computation incrementally. There are going to be failures in the pipeline that could be due to cloud failures and other failures. So there needs to be a mechanism for checkpointing and retrying. Next, there need to be a SQL quality check that needs to be built into the pipeline as well. The data needs to be governed for confidential information like PII data. At the same time, the data needs to be discoverable for the people in the organization who should be seeing it. So you need to catalog the data somehow. Even after we fulfill all of this with the pipeline, there is always a requirement from the business to backfill data that got missed. And finally, there need to be version control and deployment infrastructure management as part of the standard software development lifecycle. All of this makes the data engineering pipeline really complicated, and data engineers have spent quite a lot of time handling these tools instead of spending this time on the actual data transformation needs. The key idea behind Delta Live Tables was to bring value from data by enabling data engineers to only focus on SQL statements that do the transformation of data, rather than all other components discussed previously. Delta Live Tables are defined using simple SQL queries created and kept up to date by a pipeline. Live Tables provides tools to manage dependencies, control quality, automate operations, simplify collaboration between teams, save costs, and gives you reduced latency. By simplifying and modernizing the approach to build ETL pipelines, Delta Live Tables enables data teams to use declarative ETL pipelines, automated data validation, automated error handling and recovery, continuous always-on processing, pipeline monitoring, and simple click deployments. We're going to deeply discuss about all of these options that DLT provides in the upcoming slides. You can use the simple SQL statements given here to create your Delta Live tables. As you can see here, there are 3 to 4 stages of table creation involved based on your use case. Stage 1 is bronze table, where you create a table from your raw data. Stage 2 is a creation of silver or cleansed data table from bronze table. Stage 3 is a creation of gold or aggregated or business data table from the cleansed silver tables. And the transformation for this ETL pipeline is done via the SQL statements. You can configure these SQL statements to run as pipeline using Delta Live Table pipeline. You can develop these SQL statements in a notebook that can be scheduled to run as a Delta Live Table pipeline. Data teams can implement intelligent data pipeline in 5 steps. Step 1, by automating data ingestion into Lakehouse using autoloader that automatically detects and incrementally processes new files as they arrive and automatically detects changes to the incoming data structure. Step 2, transforming data within the Lakehouse with the power of SQL or Python. Step 3, by enabling data quality and integrity checks. Step 4, automated ETL deployment and operationalization by running the pipeline on a highly performant and scalable Apache Spark compatible compute engine. Finally, step 5, by giving options to schedule the pipeline according to the use case basis. A demo has been shown here to create Delta Live tables from a notebook. As you see, the process of creating a pipeline has been so much simplified here with just few clicks. The steps involved in creating a pipeline are as follows. By navigating to the workflow sections in the Databricks console, selecting the Delta Live tables, clicking on Create Pipeline option, select the notebook where you have developed the SQL code previously, selecting some customized options for scheduling, triggering mode, etc. based on your use case, and executing the pipeline. Here you can see how a pipeline is getting executed after it's been run. As you can see, the boxes you see in the graphs are the live tables and the arrows between the boxes of the pipeline that connect the tables. You can see the different statuses like running, queued, and completed for each of these tables, which says the status of each of the stages. Tables involved are kept up to date by the pipeline automatically, and you can see the start time, run time, and duration of the pipeline for the monitoring purpose. You can track the progress of the pipeline update by viewing the event log at the bottom of the pipeline page. Event log automatically records all pipeline operations, includes operation statistics, provenance, and data quality. DLT validates data flowing through the pipeline with defined expectations to ensure its quality and conformance to business rules. DLT automatically tracks and reports on all the quality results. You can also view the dataset schema associated and the data quality metrics such as written and dropped percentage of the dataset in the graphs displayed as shown in the video here. This is one of the most important features of the DLT, that is how to handle the invalid records. There are 3 ways in which you can handle the invalid records. First is to retain invalid records, that is the records that violate the expectations are added to the target dataset along with the valid records. The second is to fail on the invalid records, that is halting the execution of the pipeline immediately when a record fails validation. Third one is dropping invalid records, which is records that violate the expectations are dropped from the target dataset. DLT pipeline can be run in 2 modes, namely triggered and continuous mode. With triggered mode, DLT will update each table with whatever data currently available and then stop the underlying clusters from running the pipeline. Dependency between the tables are maintained here. Second is continuous mode, where the tables are continuously updated as input data changes. Once the update is started, it continues to run until it is manually stopped. Here you can see a simple demo of where you can choose or update the pipeline run mode in just few clicks by clicking on the settings and changing the mode under the pipeline mode section. You can also do this settings or update the settings when you create the pipeline from the Databricks console while creation of the pipeline. You can make the output data of your pipeline discoverable and available to query by publishing datasets to the Databricks Metastore. You can find the options to edit the settings in the Edit Pipeline settings as shown here in the screenshot. In addition to live tables, DLT supports streaming live tables. Streaming live tables are stateful because they are stateful and they ensure that data is processed only once. You can use it to read from variety of streaming sources such as Kafka, Kinesis or Autoloader or anything that is built into the Databricks runtime. And it can also reduce cost and latency by only processing new data. You can find a simple SQL statement that can be used to create the streaming live tables given here in this slide. You can select your DLT pipeline to use Databricks Enhanced Autoscaling. Databricks Enhanced Autoscaling optimizes cluster utilization by automatically allocating cluster resources based on workload volume with minimal impact to the data processing latency to your pipeline. You can also optimize pipeline executions by switching between development and production modes. When you run your pipeline in the development mode, the Delta Live Table system reuses a cluster to avoid the overhead of restarts, disables pipeline retries so you can immediately detect and fix errors. In production mode, the DLT system restarts the cluster for specific recoverable errors including memory leaks and stale credentials and retries execution in the event of specific errors, for example a failure to start a cluster. You can use any of the data sources as a source for your DLT pipeline. That includes any data source that Databricks runtime directly supports. Examples include different file types such as Avro, JSON, XML, etc. and other supported sources such as Redshift, Snowflake, Azure Blob Storage, SQL databases using JDBC, Azure Cosmos, Oracle, S3, etc. Any files in the cloud storage and any files in DBSS are the sources supported by the Delta Live Tables. DLT also provides options to schedule your pipeline according to your requirements. You can create and schedule a job with single pipeline task directly in the Delta Live Tables UI or add a pipeline task to a multitask workflow in the Jobs UI. You can see a quick demo of how you can schedule a DLT pipeline in the Databricks console as been shown here on the slide. Additionally, you can also enable alerts for start, success, and failure of the scheduled pipeline for monitoring and alerting purpose. You can use Autoloader with Delta Live Tables to efficiently move data in batch or streaming modes into the lakehouse at low cost and latency without additional configuration such as trigger or manual scheduling. Autoloader leverages a simple syntax called cloud files, which automatically detects and incrementally processes new files as they arrive. Autoloader automatically detects changes to the incoming data structure, meaning there is no need to manage the tracking and handling of schema changes. If your organization is looking to implement the Databricks platform and needs a Databricks specialist consultants to help you accelerate your Databricks journey, Daimlinc as a Databricks partner can assist you to accomplish this. Please contact us so that we can assist you further. Thank you.